Today's lesson is on our last transformation called a dilation, which is an enlargement or a reduction. To dilate a figure in the coordinate plane, we are simply going to be multiplying our x and y values of every ordered pair by a given scale factor. So if we are multiplying these ordered pairs by a scale factor, and the scale factor happens to be greater than the number 1, then we will have a product that is larger than our original numbers. So therefore, scale factors greater than 1 are enlargements. On the opposite end, if your scale factor is less than 1, meaning between the greater than 0 but less than 1, so it would be fractional or decimal values in between but not including 0 and 1, you will have a reduction. When a dilation has occurred in the coordinate plane, we can actually figure out what this scale factor is by writing the ratio. And we know that another word for ratio is fraction. So if we write a fraction using the measurements from our pre-image and our image, and we write them as a fraction in these orders, then we will know what our scale factor is. I've even got that listed at the top of the page, sometimes referred to as the new measurement over the old measurement. When I teach this to my 8th graders and they're asked to find the scale factor, I tell them this is the only time that they can tell me no, N-O, new measurement over the old measurement. Maybe that will help you remember the order as well. Example 1. We are going to dilate the rectangle shown by a scale factor of 1/3. We are then going to record the coordinates in the table. But first, I would like you all to think about the image of this rectangle. After a scale factor of 1/3, will it be larger or smaller? Our image is going to be smaller since a scale factor of 1/3 is less than 1 and greater than 0. So far in my table, all I've done is write the coordinates of rectangle A, B, C, D according to the directions above in the text box. To dilate a figure in the coordinate plane, we simply multiply the x and y values of each ordered pair by the given scale factor. To show a little work in the extra workspace for each ordered pair, and we have some repeats because after all, we only have to multiply 1/3 by 6 and attach a sign, and a 1/3 times 3 and attach the proper sign in order to get A prime, B prime, C prime, and D prime. When we multiply fractions, you multiply numerators and multiply denominators. You can also say that we are going to simplify before we multiply. And therefore, 1/3 times 6 is 2. So A prime, the coordinate, is going to have -2 in the x position. 1/3 times 3 is equal to 1. That belongs in the y position. Since all of these points were just 6's and 3's, complete the table and put the proper signs. Here are the coordinates of my image. So I've now graphed A prime, B prime, C prime, and D prime, and you can clearly tell that our image is smaller than the pre-image. To represent this dilation algebraically, we're going to write that each x, y value became a third times x and 1/3 times y. You could also write it as x over 3 and y over 3, and it would mean the same thing. Now it asks us in exercise 2 to compare the ratios of the corresponding sides. And what do you notice? So the first thing we're going to do is take a look at our new figure over our old figure. New over old. And we're going to take each segment or side piece by piece. Side A prime D prime is 2 units long, tall, high. And AD should be, if we have a scale factor of 1/3, it should be 6 units long. Looking up at my graph, I see that A is at 3, D is at -3. That confirms that it is 6 units altogether. The corresponding sides are equal to the scale factor when written as a ratio. Show the parallel set of sides in their appropriate ratio to prove the 1/3, and follow with the 2 horizontal sides. So here I have shown that the other set of parallel sides to AD, side BC, 2 over 6 is a third, and then the 2 horizontal sides, DC and D prime C prime, written in this, the ratio of new over old was 4/12. That is indeed 1/3. And then A prime B prime, 4 units long, and the AB side is 12 units long for a scale factor of 1/3. Lastly, we talk about the properties that are preserved for a dilation. So as we look back at our figure and we talk about the order of the shape, I've got side corner or vertex A is upper left-hand side of the graph, and so is A prime. For the orientation of the corners, when we name rectangle A, B, C, D, we are going clockwise. And when we go ahead and do it for A prime, B prime, C prime, D prime, we are also going clockwise. So down on our number 3 for the last box, orientation of the vertices and of the figure are preserved. They stay the same. Orientation of both the figure and the vertices remain the same. Now, this is not a rigid motion, a dilation, because rigid motions, your image and pre-image were the same size. And with dilations, we do not have the same size. But it is a transformation, which is a movement in the coordinate plane. Take a moment to record the coordinates for the pre-image. Traditionally in geometry, we go in alphabetical order and label the points clockwise. So we're going to start with E, F, G, and H. We are then going to dilate the figure by a scale factor of 2. Fill in your pre-image coordinates and determine if this will be an enlargement or reduction. Pause the video while you fill it in. Now that my coordinates are listed, we will have an enlargement of our figure. In order to apply the scale factor of 2, we are going to take each x, y value and we are going to multiply them by 2. Feel free to use a calculator, mental math. E prime will be -8, 4. F prime, fill in your ordered pair. G prime, and H prime. Then use your ruler to graph, label, plot your points, not specifically in that order. Pause the video and I'll show you mine when you come back. Compare your picture and make sure that you have nice straight lines and your prime notation on all of your vertices. Please complete number 5 as part of your homework assignment. Put 5HW. You are going to dilate the figure by a scale factor of 3/2. It may look, just by staring at that scale factor, that your triangle I prime, J prime, K prime is a reduction. But if you change your 3/2 to a decimal or a mixed number, it's 1.5. And you may use your calculator to find your image coordinates. Please revert back to the 3/2 in order to write your algebraic representation. The last skill for the dilations is to find the scale factor from a graph. And then we're going to find the scale factor from our ordered pairs. To find the scale factor, that's the only time that you are allowed to say no. It stands for new measurement over the old measurement. As I scroll back to the beginning of the notes page, and if we highlight the key information, corresponding sides and corresponding vertices, they are in the ratio of new over old. So we are going to be using our corresponding sides on the pictures that are given in question 6. You get to do question 7 all by your lonesome. In question 6, corresponding side M, N up to M prime, N prime. That's what I'm going to take a look at. And so I go to my graph paper and I see that segment MN, which is the original or the pre-image, goes from 4 to 8. So that is a 4 for a denominator in my ratio. The image M prime N prime, sorry, not a capital, sorry, goes from a 5 to a 10. That ratio is 5/4. And I'm going to leave it that way. Just because I don't trust my counting, I'm going to look at corresponding sides. L prime M prime over L M. Now we aren't able to use the hypotenuse sides at all. So we're just going to ignore that altogether. We're not going to use Pythagoras. We probably would have irrational side lengths anyway. So we're going to use any sides where we can determine how long they are or how tall they are. So back to LM, 4 to 8 for the denominator. The numerator, 5 to 10. Sorry. Is 5 units. 5/4 equals 5/4, so that is your scale factor. 5/4. To find the scale factor from a set of ordered pairs, they're just not plotted on a graph, but this is your X number, that's your Y number for one coordinate. That is just your pre-image. That is your old, if you want to call it the new over old. Here's your new point with an X and a Y. From the ordered pairs above, in question 6, we looked at how long the segment from M to N was, and we used those X values to find their length. And then we found how long the side was from L to M and used the corresponding sides. However, we just have points right now. We don't have two ordered pairs to be able to compare the new over the old in as a subtraction problem. So this is not slope. We are just going to take the actual digit because after all, when we took a scale factor of 2, we doubled each X, we doubled each Y. If we're working backwards, we're going to write the division ratios. So let's just use those points. We've got the new point, 6, over the old point, 9. And then we have new point, 8, over old point, 6. Sorry, it's not a 6, it's a 12. Eight over 12 simplifies to 2/3. 6 over 9 also reduces to 2/3. Your scale factor is 2/3. Please complete 7, 9, and 10 also for your homework. So you have 5, 7, 9, 10, and the last page as your homework this evening.